You are listening to WTUZ Radio Podcast.
This is Rhonda with WTUZ Radio Podcast. This particular podcast, it is based on information sent to me. Shout out to Sis Tressie. I finally was able to get to it, Sis. So this is going to be twofold. One is something new. And we've been talking about it, and Sis Tressie ran across an article. And then another one I found a couple days ago, and I just decided to put them together and let's have a discussion about it. But they are both follow-ups, okay? So, child, I'm really technically supposed to be taking a break. But it's been so much stuff coming out that I had to put out. It's like I'm doing something every day. So bear with me, fam. And thanks so much for being patient with me and for your support. Okay, so the first one, we're going to start with Sis Tressie. I can't share it with you all because for some reason, when I try to pull it up on the internet, via my computer, it's trying to make me pay for it. But if I do it on my phone, I don't have to pay for it. So I'll give you the source. And of course, I will drop it in the description so you can see it for yourself. But this first article I'm about to read, for some reason, I had trouble with trying to open it on my computer without paying for a subscription, but I could do it on my phone. Okay, so this is from Hereditary.com, and the title of the article is "A Decade After Crispr Discovery, the Unimaginable Outcomes of Gene Editing Emerge." CRISPR-based cures will soon help combat all kind of disease from UTIs to leukemia. But terrifying implications of gene editing are abound also. Interesting. I heard something in passing about there being a cure for leukemia literally this morning, and I came in on the tail end of it, so I couldn't catch the entire content. So that's interesting. I'm just looking for a date on when this article. Okay, yeah, this is recent. This was 2 days ago. Okay, so shout out to Sis Tressie again. So it says Nobel Prizes in the sciences are generally awarded after a few decades of meticulous research. Indeed, usually many years are required for the greatness of a scientific discovery, its contribution to humanity, and its positive implications for the realm of science to be grasped. But in the case of Jennifer Doudna and Emily Carpenter, the Nobel arrived with record speed. Their groundbreaking study was published in the journal Science in 2012, and last year the Nobel Committee for Chemistry deemed them worthy of the prestigious award. Anyone who has in recent years visited a laboratory where research is conducted in the life sciences will know the reason for the panel's decision. The mechanism the two scientists developed, known as CRISPR, and for you all, I know y'all have seen this before, is CRISPR. Okay, I know that's an acronym for something, y'all. is used in almost every experiment in biology, whether it deals with human beings, animals, plants, or microorganisms. Since 2012, the number of studies using the technology has doubled every year. By now, it has been cited in more than 485,000 scientific articles and in more than 1,000 patents. Okay, so child, they finna make me go search that patent database to see what they behinds is up to. Child. What is CRISPR? If DNA is comprised of letters, which together form words, and they put in parentheses genes, which constitutes the instruction manual for the production of proteins that are responsible for all our bodily actions, when Doudna and Carpenter have offered the world, what they have offered the world are the function keys for DNA cut and paste. Child, let me sip my water. Child, Sis Tressie be on it, boy. You always sending me some stuff. Child. You say what now, article? Although we've been knowing this, right? If you study those Sumerian texts and they were doing those genetic creations, child. Now what we're being shown today is pretty much how they were doing that stuff. So just to recap, because I don't want to gloss over that. So if DNA is comprised of letters, and we all know that, they comprised of those letters, and depending on how those letters are ordered, constitute what type of species it is. Okay? Which together form words, which are genes. So do y'all understand when they talk about up in that Bible, let us create man, and they talk about things being created based on the creators speaking it? Were they really talking about DNA? Okay. Says, so, which together form words / genes, which constitutes the instruction manual for the production of proteins that are responsible for all of our bodily actions. What Doudna and Carpenter have offered the world are the function keys for DNA cut and paste. That is using CRISPR technology. Scientists can easily cut out whatever specific DNA segment they want and then allow the genome to repair the missing segment by itself or replace it with the desired segment. Boom! Ain't that creating another species, altering an existing species? Child, let's continue. Two scientists, Doudna from the University of California, Berkeley, and Carpenter, who heads Berlin's Max Planck unit for the science of pathogens, had already appeared on Time magazine's list of 100 most influential people in 2016. The press release for the 20 20 Nobel Prize in chemistry stated that they were being given the award for discovering a tool for rewriting the code of life. Child, I'm done. And of course, they put in parentheses, a tool for rewriting the code of life. Child, they better stop playing with me. They better stop playing with me. So, just a refresher, when you read in those Sumerian texts them talking about multiple beings or species being created, and when we were reading that, we're like, okay, so ain't that like gene slicing and genetic engineering? Child, let's keep on going. The journal Nature described the result of their research as a discovery that changes the rules of science. You mean that BS science that you put out to the public while you all had the real science, the ancient science, and the natural science hidden as you all were trying to reverse engineer what the ancients already had already been documented? You mean that science? You mean the science that them Anunnaki beings used and they only gave to their specific bloodline, that particular science? So did somebody slip you all some of that information out of one of their ME bags? And you all been trying to reverse engineer it? And now you're starting to release these things to the public? You mean that new science that ain't really new? Okay, let's continue. It was obvious from the start that the new technology was bursting with potential, and a decade later, it's also obvious that its immense potential is being realized. It's no longer fantasy, but reality. Doudna, 57, tells Haaretz in the first interview she has given to an Israeli media outlet since being awarded the Nobel. Crisp, I think it's Crisp. Yeah, I'm saying Crispr. I think it's Crisp. Is already curing many diseases. There are numerous clinical experiments that are making use of Crisp, and soon some of them will become part of the medical possibilities that are available to every person. It is very exciting. Child. Remember, I told you all that we're going to start seeing over these next 5 to 10 years a rapid change in the technology and medical area, because they're going to start releasing this technology, which is really not new, by the way. We've talked about that several times. It's not new. They're just deciding to re-release this stuff. Okay? So you're going to see huge leaps from a medical perspective, which is a good thing. Absolutely. No doubt about it. That's a good thing. Especially when it is using the natural sciences. Now, as far as this DNA slicing and dicing, no, they can go on somewhere with that. Okay? I'm side-eyeing that big time, because that lets me know that you're doing some Inky them stuff. And Inky's sister, who was really the one that was the geneticist, she was really the true scientist. you're trying to create a new species. You're trying to create a new species to fit into your AI world. Now, that's just me. That's just the conspiracy theorist in me with the tinfoil hat on. That's okay. I'll wear that. That's just me. Okay? But yes, using the natural sciences / technology for health purposes, absolutely. I'm in full support of that because that's what should have been used all along and never should have been hidden from us in the first doggone place. Okay? So, let's continue. Indeed, a series of studies in this realm around the world are now entering the final stretch. I told y'all. CRISP based cures will soon be available to help combat diseases that affect millions of people everywhere, from urinary tract inflammation, muscular dystrophy, genetic blindness, and immune system failure to AIDS and leukemia. Child. I just saw y'all. I'm chilling, minding my business. There is a commercial running, family, where there are eye drops. Was it a commercial? No, it wasn't a commercial. I take that back. It was probably 60 Minutes, y'all. I think it was 60 Minutes. Either 60 Minutes or CBS Sunday Morning. I try to hit those up every week because they have gems like that in there. Anyhow, they were talking about, and I'm going to see if I can pull that for the fam and we can go over it. Child, they talking about some eye drops where they done developed these eye drops where you could put the eye drops in your eyes and you will have 20/20 vision. So I'm going to try to pull that clip for you, fam. And I'm like, and they starting to release all of this stuff. Okay, so now in this, they're saying CRISP is going to be able to cure what? UTIs, muscular dystrophy, genetic blindness, and immune system failure to AIDS and leukemia. But curling diseases is only one side of CRISP. And y'all forgive me if my country behind is not pronouncing it correct. If it's CRISP or CRISPR, just forgive me up in advance. Using the technology of gene editing, scientists have also succeeded in eradicating mosquitoes that spread malaria, dealing with the resistance of certain types of bacteria to antibiotics, diagnosing diseases, creating test kits for C19, producing an improved type of biological fuel, and even advancing the idea of implanting organs from pigs and humans. That one kind of made me scratch. Okay, so that's a lot of stuff. So they talking about some also okay, eradicating the mosquitoes. That's interesting. All right, let's keep going. And even that is only part of the big picture. In agricultural, too, a wonderful opportunity exists to use this technology to change one gene or more in plants. Dodna says, changes can be made that will lead to plants' resistance to aridity, to increase crop yields, and to help cope with the challenges of global warming. From the perspective of agriculture, this technology arrived at the right time. So those of us that are gardeners, usually how you change the quote, quote, genetics of plants, it's just like you would in the human species, which is what, done through breeding. Okay, so the same thing can be done with plants. You take the strongest of the plant, or you take that plant with that certain genetic trait and you mate it with another plant, and that's how they come up with the different species of plants. Okay, or do grafting. So now they talking about going to the DNA level directly and changing the DNA of one species, making it into another. Oh, child. So some inky them stuff, basically. Same what they talking about the humans. It's the same thing they talking about with the plants. Child, seems to me that they're totally trying to build new species all around, from the people to the plants, and mix it in with the new virtual reality. This is interesting. This is very interesting. Now, that's just me with my tinfoil hat on with that last part. So let's continue. These opportunities are already being realized by researchers worldwide, including in Israel. Crispr is making it possible for scientists to transform wildflowers into, okay, they just proved my point, wildflowers into fruit-yielding plants to bolster the resistance of field crops to diseases and pests, to grow potatoes that contains more starch, even to help purple flowers morph into white ones. I'm still trying to picture the wildflower into fruit yielding plants. Child. This is also just proving my point when we were doing the series Mama Tara and the Consciousness of Her People, and also in some of the podcasts in the series Old World Tech Hidden in Plain Sight, that the entire realm itself that we see today is not the original realm, and it was manufactured, it was changed through technology. This straight proves my point right here. This stuff is not new. It's not new. It's not new at all. On the top of this, local researchers are using the technology to prevent chickens from laying eggs containing male chicks, to breed healthier sheep, and to increase the amount of protein in fish. Child, they making me straight sit up here and scratch and itch. Whoa. All of these scientific advancements, some of which were until recently in the realm of science fiction. No, boo. Science fiction always, for the most part, tells the truth. And us sci-fi heads been told y'all that. But no, we were labeled as crazy and conspiracy theorists. But yet, pretty much those sci-fi pics, that technology that they were showing you in sci-fi, now they're bringing forth that same technology. No, that technology was already around. Okay? It was just hidden for whatever reason. Okay? Because those that control the realm are determining what technology is going to be used when. And now they're deciding to re-release this old technology. And what's tripping me out, it's coming so fast with the technology because folks, talk about Nikola Tesla, which I do as well. The difference is I tell you that he was not the first discoverer of that. That he was really just reverse engineering or taking a blueprint from existing old hidden ancient technology. Okay? And he studied metaphysics. He studied metaphysics. Okay? Which is really just the quote, quote, natural sciences. So not only are we seeing stuff come into fruition with things that Nikola Tesla had brought to the forefront in the 1800s, 1900s. Now, baby, they pulling out the quote, quote, big stuff and going back to those ancient texts on the planet and bringing in that technology. So this is really, really, family, this is an interesting time. I'm putting time in quotations that you are living through. Literally. This is a huge, huge reset. And they are implementing it right before everyone's eyes. And as usual, 90% of the population don't, and I'm going to even put that up to 95% of the population don't even realize what is going on. And they're moving fast with it. Okay, so let's continue. So all of until recently in the realm of science fiction, are opening up more and more paths for research, which are in turn growing ever more ramified. Along the way, it turns out that it's necessary to trod on some of these paths with extreme caution. In some cases, it seems that some are actually best left untrod. The co-discovery of CRISPR came from curiosity-driven science, notes Dodna, who is naturally aware of the serious moral issues that have arisen in the wake of technology, particularly in regards to the possibility of editing the human genome. And don't think it was not lost on me that they have women who, quote, quote, discovered this technology. I just go back to the ancient them Sumerian texts where it was Enki and Enlil's sister who was the geneticist. So that ain't slipped me either. So you say, what now? You feel that it's a serious moral issue that have arisen in the wake of technology, particularly in regards to the possibility of editing the human genome? No kidding. Deeper into our team's research, we realized the amazing programmable of Crispr and its potential as a genome editing tool. Child, ooh, baby. I didn't almost sip down 20 ounces of water within a few little minutes. Oh, man. So they are admitting that they can not only edit the genes, they can program it. Child, Sis Tressie. Child. It was then that I started to consider the ethical implications of technology more deeply. Genetic scissors. Baby, this is slamming. Crispr stands for, thank you. I knew it stood for something. Clustered, regularly interspaced, short, palindromic repeats. A long name for the section of DNA in bacteria that protects them against viruses. Child, I done learned me something today. Ooh, baby. Doudna and Carpentier succeeded in harnessing the mechanism used by the pieces of bacteria to enable gene editing of any organism that possessed a genome, i.e., a genetic set of instructions. That's all life, family. Do you understand? That's all life. The two scientists didn't discover Crispr itself, but rendered the whole complex genetic system more effective and comprised of just two components, RNA and the Cas9 protein. In their famous 2012 article in Science, they explain how they programmed the DNA cutting mechanism in unicellular bacteria called Streptococcus progenes to make it capable of exercising any kind of DNA in the world and thereby creating genuine genetic scissors. Like I said, that's all life. So now, when y'all look at those pictures from, mythology, when they're showing like a lion head on I don't know. Y'all know what I'm trying to say. A lion head with wings. A lion with wings, or we've been talking on the comment sections about them ancient maps in Africa, or that ancient map in Africa that showed these particular creatures underground that were misshapen. Okay, and then you got, a fish head on this one, all of that type of stuff that you see in those quote, quote, mythologies. Was it really mythology? Or was that a case of gene editing and genetic scissors? They also show how to use RNA to insert a desirable genetic piece in place of the one that was edited out of the DNA. In one fell swoop, their innovation rendered an entire technology simple, cheap, and accessible. Child. There are now dozens of biotech companies worldwide that sell CRISPR technology to laboratories. All that's needed is to determine which genes are to be removed and which are to be inserted in their place. You can even order a CRISPR kit online. Baby, they better stop playing with me. The costs range from a few hundred to a few $1,000s, depending on the complexity of the procedure involved. A simple example of how CRISPR changed all the rules of science is a new treatment for 2 hereditary diseases that are caused by one flawed gene. The first, thalassemia, which causes a drop in the production of hemoglobin, compels the 280 million people who suffer from the disease to receive blood transfusions throughout their lives. Okay, so I guess that's the people that their blood don't really clot, if I'm remembering properly. The second, sickle cell anemia, which affects approximately 4.5 million people, causes the red blood vessels to take the shape of a sickle instead of a round pallet. So it becomes difficult for them to carry oxygen to various parts of the body. In 2019, the American firm Vertex, one of the world's 15 leading pharma companies, started to develop CRISPR based on medication for the 2 diseases. Just 2.5 years later, the medications were proven a success in clinical trials and are now in the process of being approved. So wouldn't that mean that if they take the medicine in, that will alter their genes to, wow, yeah, this is deep. This is deep. With the discovery of tools such as CRISPR gene editing, we now potentially have the opportunity to address diseases at their root cause. Rob Clark, communications director at Vertex, tells director at Vertex. These are lifelong diseases that have a significant impact on people's lives, on people's daily lives, and consume substantial healthcare resources. We are investigating the use of gene editing technology to see if we can discover and develop a one-time potential treatment for both diseases, Clark says. He explains that blood is collected from patients, and then using CRISPR, the genes in the blood stem are edited. Okay. Example, the flawed genes are cut away and replaced before being refused back into the patient as part of a standard bone marrow transplant. Baby, they better stop playing with me. Woo, child. The 15 participants in the thalassemia clinical trials are now transfusion independent, Clark notes. So the hemoglobin people whose blood don't clot, basically, yeah. Okay, so they got 15 folks, and now they don't need transfusions no more. Wow. While those who took part in the sickle cell disease trial are free of vaso-occlusive crisis, namely severe pain events caused by the blockage of blood vessels. Child. He admits that it's premature to talk about the future costs of such treatments and how accessible they will be, but if the procedures are adopted by the public health systems, they could be made available in every hospital in the world. Adds Clark, it is imperative that the appropriate healthcare infrastructure is in place in countries to allow for access to gene editing technology. Ooh, child. So now, family, do we understand why they had started that Genome project way back when? Do we now get why the DNA test kits are being pushed so heavily? Which, folks were skeptical about turning over their DNA, including myself. Okay, although it's not like they don't have your original DNA. If you were born in a hospital, they absolutely have it. But I suspect that the DNA testing that they are voluntarily putting out there, because you volunteer, you give your consent. They wanted to look at the codes of the populace to see where the current DNA stands. Child. CRISPR-based treatments are currently also leading to breakthroughs in cancer medications. Last year, findings were published following the first clinical trial in this field that involved CRISPR-based treatments. In the study, which was aimed at inhibiting the development of lung cancer and was conducted at Xi'an, or I'm just going to say Xi'an University, China, a dozen patients were injected with immune cells that have undergone gene editing, which enabled them to combat cancerous cells. The findings, which were published in the journal Nature Medicine, showed that in 11 of the 12 patients, the altered blood cells were still in evidence 2 months after the transfusion. The higher their proportion in the blood, the bigger the reduction in cancer cells. Similar clinical trials were carried out at the University of Pennsylvania on 18 individuals suffering from different types of blood cancer, and the treatment has so far been deemed successful. Closer to home, the laboratory of Precision, Sis Tressie, dang girl, I needed a gallon of water sitting next to me to go through this. Closer to home, the laboratory of Precision Nanomedicine at Tel Aviv University, under the direction of Dan Peer, is also working on developing a cure for certain types of cancer by using gene editing technology. So nanomedicine, huh? Let's continue. Here, the system is different. Professor Peer carries out gene editing in the cancerous cells themselves, not of the immune system that is geared to fight them. He has, for the first time, succeeded in halting the development of cancer in cells with the aid of CRISPR, and says clinical trials using his method are set to begin next year. It's complicated to cure cancer by means of CRISPR because multiple genes cause cancerous tumors. So even if you remove one gene, there are others that might be active, Pierce says. Even so, we were the first to show that it is possible to execute gene editing of cancerous cells that affect an entire organism. in our case, a mouse. Today, we are on the brink of the era of personalized medicine, and this is a key tool in that realm. An important opening has been created in the field of cancer medication. Ciao. The same picture exists with respect to AIDS medicine. Recently, an American pharmaceutical company received FDA authorization to launch clinical trials for CRISPR-based treatment. Here, the researchers draw blood from AIDS patients, edit the DNA of their immune system so that the HIV virus will not be able to attack, and then re-infuse the blood in the hopes that the edited cells would grow and spread in the body. Examples of other uses for gene editing abound. Clinical trials are expected to begin soon towards a cure of Duchenne muscular dystrophy, a severe disease that causes premature death. The scientists from Southwestern University in Georgetown, Texas, who developed the treatment, have already used it successfully in dogs suffering from the disease. Similarly, Intellia Therapeutics, an American company that develops biopharmaceuticals using a CRISPR gene editing system and is proposing a host of creative applications for it, is currently launching clinical trials that focus on the heart and liver diseases that are caused by a genetic defect. I believe that in another few years we will be able to cure familiar diseases like diabetes or Parkinson's. John Leonard, Intellia CEO, tells Haaretz. In these diseases, the trials are still at the stage of searching for the locations in the DNA which will undergo editing when the time comes. Ciao. People suffering from what's called severe combined immune deficiency or SCID diseases, those once known as bubble babies because they were compelled to live in an isolation bubble, may also find relief soon thanks to CRISPR technology. Okay, so y'all remember, now there's a movie with John Travolta, and that's when he was young, y'all. I mean, real young. It's called Boy in a Bubble. Okay, so that's the disease they're referring to. Dr. Eyal Hendo from the Genome Editing and Gene Therapy Laboratory at Bar Island University and Professor Raz Somek, director of the Pediatric Immunology Unit of Sheba Medical Center, Tel Hashmaner, are co-researching a cure for SCID. So that's the boy in the bubble thing I was talking about, or that immunity disease, by means of CRISPR, and are on the brink of clinical trials. We cut away the flawed gene and replaced it with a segment of standard DNA, Hendo explains. So, I mean, fam, just from that right there, that tells you they can create another species. If they can cut away a segment of the DNA and then replace it with another one, child, I'm true baby. Adding that the treatment being developed will be administered by means of a regular bone marrow transplant. There are also diseases that are less complex but more widespread that may be treatable by way of CRISP. One example is the inflammation of the urinary tract, which affects more than half of the women in the world. Urinary tract infection caused by harmful bacteria is usually treated with antibiotics, but the American pharma company Locust Biosciences recently developed a new technology. The company's scientific manufactured a cocktail of 3 viruses that attack UTI bacteria and carried out genetic alterations of certain sections of the viral DNA as a result of which they then attack the strands of bacteria responsible for the overwhelmingly majority of these infections. The clinical trials conducted last February were successful and produced no side effects. Developments of this sort are of significance not only in curing diseases that degrade the quality of life of billions of people around the world, but in helping to counter one of the major medical challenges of our time, the high resistance of bacteria to antibiotics. Yep. Transplants from pigs. Child. CRISP. Applications in the realm of medicine are now, before I go there, now some people say that the pig itself is a highly genetic engineered species, that it was genetic scissored from other species. So I don't know if that's true for sure, fam. I'm just saying what a lot of people are saying, and a lot of religious texts say don't eat that swine. So I'm just finding it interesting that they using pigs in this genetic scissoring situation. So it says CRISP applications in the realm of medicine are not confined to treatment of disease. One of the most talked about uses of the technology is related to the effort to develop organ transplants for humans from pigs. Child. I'm good on that. I'm good on that one. No, I'm good on that one. A significant challenge here is the danger that the recipients will be infected by viruses that originate in swine. Yeah, my point exactly. I'm good on that, blood. Yeah, that's a hard no for me. Scientists in the labs of the eGenesis company, founded by the well-known geneticist from Harvard Medical School, Professor George Church, have already succeeded in breeding dozens of pigs that are resistant to those viruses by genetically altering their DNA, with CRISP technology. In addition, the company is working on solutions to prevent the rejection of the implanted organs. They better stop playing with me now. I remember seeing in one of those mythology texts with people walking around with a pig face in a human body. But remember, that was just mythology. Child, they got me all the way messed up. The technology can also be used to prevent diseases, for example, malaria. Researchers from Imperial College London were able to edit the DNA of malaria-transmitted mosquitoes to prevent the females from laying eggs. Ooh, I'm just scratching y'all. Indeed, the mosquito population that was used in the anti-reproduction experiment became extinct within 8 generations. Let me run that back again. Indeed. Well, let me back that up a little further. To prevent the female from laying eggs, so wouldn't that make her sterile? Indeed, the mosquito population that was used in the anti-reproduction experiment became extinct within 8 generations. Because y'all know how many dang on mosquitoes there are. The system of propagating an engineered gene among an entire population is known as gene drive. Child, I ain't even going to be able to combine this particular podcast with the other stuff. That's going to have to be a separate podcast. Baby, wait a minute. Wait. The system of propagating an engineered gene among an entire population is known as gene drive and is executed with extreme caution out of fear that the alteration will undergo unintended mutation and impart a new and undesirable trait to that population. Boom! So what they were showing us in those mythologies with those half-looking human things and those animals that were mixed, baby, this is exactly what they were doing back up in the day. Let me just back that up again. The system of propagating an engineered gene among an entire population is known as gene drive and is executed with extreme caution out of fear that the alteration will undergo unintended mutation and impart a new and undesirable trait to that population. In the Imperial College Malaria study, it emerged that the gene drive transmitted a desirable trait, sterility or sterilization, in 100% of the cases. Child. So wiping out a population, right? Nevertheless, the tool has not yet been approved for use outside the lab. They better stop playing with me. Crispr is also rapidly dominating the realm of diagnostics. How does this work? Crispr identifies the DNA segment of a particular virus or bacterium, exercise it, and replace it with a section that lights up or assumes a specific color in special diagnostic kits. If the test produces the light or color, that means there is an infection of the same bacterium or virus. If the original color remains unchanged, there is no infection. These kits, which are usually cheap and easy to use, are becoming more common in hospitals, clinics, and are also for home use. Child. The most familiar example of this are the home kits that test for C19, which work according to the same principle. In Professor Doudna's lab in Berkeley, for example, researchers were able to manufacture a swab test for C19 detection that provides results in 20 minutes. These kits are not yet being marketed in Israel, but have been approved for use by the FDA and will likely be in use worldwide soon. David Bernstein completed his postdoc in Datna's lab 3 years ago and is now a researcher in the Shumanis School of Biomedicine and Cancer Research at Tel Aviv University. At Berkeley, he looked for CRISPR systems which originate from viruses that are different from those studied by Dabna and Charpenter. The Cas9 protein for cutting DNA, which Jennifer and Emmanuel discovered, is the most familiar and is considered one of the most efficient enzymes discovered to date, Dr. Bernstein says. But there are other Cas proteins that possesses different traits. Some are smaller, for example, which are capable of executing actions that are sometimes more precise. Bernstein has published 2 articles about the Cas proteins he's found in Nature and in Science. He is currently working with Cas12 proteins in developing viral and bacterial diagnostic kits in cooperation with Dr. Gur Pines from the Volcani Center and Agricultural Research Organization in Rishon LeZion, and he is examining whether it's possible to use CRISPR-based diagnostic kits in space. Eitan Stibbe, who is slated, or Stibbe, who is slated to become the second Israeli astronaut, will take with him to the International Space Station 2 kits and will examine the way they function. When you're in space, you don't want to have to resort to clumsy instruments that require expertise to operate. The kit we are checking is a small one that offers easy and fast diagnostics for identifying the substances that cause disease. That will make it possible for astronauts to know whether they have an intestinal bacterium or whether their stomach is just trying to adjust to their lack of gravity. Oh, chow. Crisp food. The Journal of Food Science chose in 2015 to devote its gala 75th anniversary issue to CRISP and to the future promise the technology holds for the realm of food. In an article titled CRISP-Based Technologies and the Future of Food Science, Kurt Selle and Rodolph, both of North Carolina State University, note that although the ongoing CRISP craze is focused on the high potential for medicine, CRISP-based applications are now poised to revolutionize many fields within food sciences from farm to fork. Yeah, why I'm thinking of Soylent Green. If you all have not seen that movie, it's old school, y'all. Old school. Go check it out. Soylent Green. Go check it out. Researchers of agriculture are especially fond of CRISP because it is not considered a technology involving genetic engineering, rather gene editing. In genetic engineering, a stretch of DNA from a foreign organism is inserted into desired organisms. For example, DNA of a locust-resistant bacteria is merged with corn DNA. In contrast, in gene editing, DNA of a plant or animal is only cut away without foreign DNA being inserted in its place. Child, let me reread that because I couldn't have read what I think that I read. DNA of a plant or animal is only cut away without foreign DNA being inserted in its place. Okay, but Ain't that still editing the DNA of the plant or animal? Okay, I get what y'all saying. You're going to cut out that part of the DNA that's causing what you don't want in that plant or animal, but ain't that still editing? The first commercial editable product to undergo gene editing came on the market in the United States in 2018. It's a soybean cooking oil called Calino, created from beans genetically edited to give them a reduced amount of unhealthy trans fat. According to Wired magazine, Caltech, the company that manufactured Calino, describes its oils as having a heart-healthy fat profile of olive oil without its strong, sometimes grassy flavor. Nah, I'll stick to olive oil. I'm good, blood. I'll stick to olive oil. The product isn't yet being marketed in supermarkets, being sold only to a few American food chains and restaurants. Of course, because in America, you know, they don't care about experimenting on their population regarding food. Nah, they don't care at all, which is one of the reasons why Americans have the highest obesity rate on the planet. Nah, they don't care, which is why Americans' food supply is just straight garbage. Nah, they don't care. Yeah, that's about right. That's about right. Yeah, you able to sell the genetically gene sliced, gene edited oil to the American population. Oh no, we cool with that over in America. American food chains and restaurants. Still, this marks an important moment in agricultural history, the onset of an era of gene-edited foods that have undergone changes not only to make life easier for farmers, but also to make life healthier for consumers. Okay, so now you fencing to make it healthier for us when you made it unhealthy from us in the first place? Because we're maybe 2 generations in? Well, now 3. I was including myself. Now 3. Really 4. If you include the really, really youngins. Generations in of the dependency of the food supply chain versus when grandma and them and papa and them had majority of the food coming up out their garden, and then they partner with someone up the street if they didn't have the cows and the pigs. They partner with somebody else up the street that, manage cows or whatever for their meat, but they always had them chickens in the backyard. So literally, farm to table was literally just out of mamas and papa and granny them garden. And hence why everyone was much, much healthier. And they lived a lot longer. And then the dependency started being as folks moved to the cities and didn't have the, quote, land space to farm. And quite frankly, just didn't want to farm because they were occupied with working in the factories and all of that type of jazz. So the grocery stores became really popular. And then the small farmers started getting bought out by the big farms that started mass producing the food, which made everything a lot unhealthier, not to mention the introduction to the processed foods and chemicals, which ideally are like much, much, much cheaper than the healthy stuff. So you mean that particular food supply, but now you want to go back to making it healthier, and you want to do that through gene editing. That's what you want to do it through. Not do it through promoting sustainable farming, permacultural farming, neighborhood farming. Oh, no, not that part. We just gonna edit the genes of the plants to make it healthier. Not reversing it with taxing the heck out of the processed foods. And then in a lot of cases, just outright banning the processed food. Oh, no, not that. We got to go gene edit the vegetables. We got to go gene edit the animals. Oh, okay then. Because you want to make it healthier. Okay. But let me continue. Let me go ahead and continue. In Israel, too, which is the forefront of agricultural research and development, Crispr has made its debut with a fanfare. Last year, a National Center for Genome Editing in Agriculture was established, an umbrella organization encompassing about 30 groups of researchers from 6 different institutions. Its goal, according to Dr. Amir Sherman from Volcani Center, who is coordinating the organization's activities, is to create agricultural products based on genes. Dang, I lost my place. Gene editing, and to establish scientific infrastructure in this field. In the meantime, various crops are being examined within this framework, including wheat, barley, apples, squashes, melon, cucumbers, and watermelon. Ciao. Wow. Let me read through the list now. In the meantime, various crops are being examined within this framework, including wheat, barley, apples, squashes, melons, cucumber, watermelons, peppers, potatoes, as well as fish, sheep, and chickens. Ooh, chow. Damn, y'all. And I'm looking for all the things that I grow. And that's 1, 2, 3, 4, 5, 6, 7. So that's 7 on the 7 out of this list that I personally grow. I don't grow wheat. I don't grow barley. I don't have a fish farm. I don't have sheep. I technically do not have chickens, although my neighbor's chickens be up in my yard. But I technically don't have chickens. Wow. Yeah, this is deep. And it makes sense why, how many years ago? 4 years ago or whatever, I started stockpiling seeds, and all of us in our little farmers club started stockpiling seeds, and that even is down to the, they call them the heirloom seeds. Okay? This mess is deep, honey. This is straight up deep. And the other thing I wanted to say regarding watermelons, I don't remember who told me this, but it was a brother, and he said that watermelons are really a cross between, damn it, what did he tell me? Strawberry and something else. It was strawberry and some type of melon. But anyway, he was getting at that a watermelon was pretty much created. Damn, I can't think of the second thing that brother said. All right, so several. Oh, and he actually told me that it was, he said the Moors was the one that came up with a watermelon. I hate that I can't remember the second thing that it was crossbred with. But I know strawberry was one. All right, so several research groups are working with fish so that the length of time they spend in the breeding pond can be shortened to yield the same amount of protein, Sherman relates. In another project, a group of researchers succeeded in breeding St. Peter's fish without their typical black stripes, which might prove popular in the Asian market where there is a preference for reddish fish. Ain't that deceiving them, though? As for the sheep project, a system of gene editing is being developed with the aim of improving the health and reproduction of ewees or eves. Research are also currently experimenting with CRISPR technology to perform in vitro fertilization of sheep embryo. Now, we talked about that too when they were doing all of this gene scissoring or gene editing, and we were like, well, how did they get the new species to emerge? And I said it had to be in vitro. It had to be, or artificial insemination. Child, they better stop playing with me. The technology is also being used to improve the shelf life of potatoes and to create resistance to diseases in squash and nightshades. I pass on that too. Although squash is the hardest veggie with diseases. I have to watch it like a hawk because it will infect your entire garden. Okay. And 1 year I totally ripped that bad boy out. It was it butternut squash? Can't remember if it was butternut squash or spaghetti squash. And I saw, because I was trying to treat it, well, that was before I knew about a natural insecticide. And guess what it was, y'all? Copper. Yep. Copper water. Treats the fungi. So I was battling. I was trying to, because I didn't want to use chemicals. I wanted a natural solution. So in the meantime, I'm like, okay, I'm going to try to leave you in here, not knowing that fungi would spread to the other plants. And then I started seeing the mold on my other plant. I said, oh, hell no, you out of here. So I ripped it out and got it out of there. But then that's when I found the research that I could treat the fungus with a copper solution, and which now to this day in my garden, I use a copper solution just to be ahead of the game, to make sure I don't get any fungi. So I can see them, although I'm not messing with the squash that they gonna sit up and gene edit. I'm gonna pass on that. But I'm just letting you know that squash is highly susceptible to diseases, fungus diseases. Specific squash is butternut and spaghetti squash, which are two of my favorites. Okay, not so much the zucchini. But so if you're starting out in gardening and you want to give those two a try, as a matter of fact, I don't even try to plant those anymore, to be real honest, because I just don't be feeling like being bothered with them. But if you are dabbling in growing those two, automatically get you some copper insecticide and out the gate, spray your entire garden down with that, because there's a highly chance that once you see that fungi come into place, it's going to be coming from those particular two squash. All right. Okay. So sorry. Okay, let me get back. Let me get focused. I'm sorry about that. Several research groups are developing ornamental plants such as cryosanthemums that are not affected by the amount of daylight. Child, they better stop playing with me. They're exposed to. Another group is engaged in creating vines that can be grown in a hothouse. Child. Two research groups are working on gene editing of tomatoes. Tomatoes, y'all, has been one that's been highly already, not gene editing the way they're describing, but crossbred, big time. That's why there's so many variations of tomatoes. So this does not surprise me. I was waiting for them to bring up tomatoes. One from the Hebrew University of Jerusalem is aiming to intensify the plant's red color, while the other from the Volcani Center aims to improve the tomatoes plant's resistance to disease. Okay. And I'm good with that too, because tomatoes really don't need that type of gene editing, y'all. Just from a gardener, you just really don't. You already pretty much know what type of tomatoes to plant. I have gotten bougie in my planting of tomatoes, and I plant, stuff that you can't buy in the grocery store. Okay. This was my second year, but I really got a good yield this year of planting black tomatoes. And child, I don't even like how they taste. All of that. I did that bad boy from seed, got them to grow. I'm like, ooh, let me taste that. Yeah, got it in the house, tasted it. I'm like, that's a little too bitter. But once you leave them on the vine, they eventually turn red. So yeah, I'm good on the tomato stuff, fam. I wouldn't personally mess around with any of this genetic editing. But for tomatoes, no, us gardeners, like, tomatoes already are pretty sophisticated. But all right, whatever. Let's see what they're talking about. That group is led by Maya Barr, head of the Laboratory for Plant Pathology and Weed Research in the Center's Plant Protection Unit. And as far as making tomatoes redder, all you have to do is put under, like on the ground of your tomato plants, something with the red reflection. And I think they even sell them. I've never had that problem. They even sell them. I know they sell them. And the sun hits that thingy majig on the ground, and then the reflection hits the plant, hits the tomato fruit, and it makes it redder. So I'm good on that too, blood. Although I've never had that problem of my tomatoes not being red enough. But I guess if you're in an environment where they're not getting enough sunlight, that could happen. But no, us gardeners know, we can just go and get that tomato ground thingamajig, and we're good. So we're good on that also. We are working on a number of projects that will make tomatoes more resistant, Dr. Barr relates. One project is being carried out in cooperation with Tel Aviv University, where it was discovered by chance that a particular form of gene editing renders tomatoes more resistant to fungi, bacteria, and also to certain pests, such as moths. Okay, so I already done gave y'all the gardening solution on fungi. It's a copper insecticide. Child, I'm sorry, this done turned into some gardening stuff. But doggone it, they brought it up. It's a copper insecticide for pest, neem oil. Yeah, neem oil that comes from a tree. Get the pure stuff. Don't go up in Lowe's, Home Depot, and get that spray because it's so watered down. You're going to be pissed, and then you're going to be like, Rhonda don't know what the H she talking about. Go get the pure neem oil. Okay? It's literally an oil, and it is so safe that you can literally use it on your skin. All right? They use it in India because it comes from a tree. And that stuff is strong, baby. So you have to use the oil. I know you can get it from Amazon. You can get the pure thingy from Amazon. And if you get a gallon, if you don't have a big garden, that stuff gonna last you multiple years because you dilute it. So what you do is take that neem oil, get you a spray bottle, put so much in it. You know, black people, this just like seasoning food. So I can't sit up here and tell you a teaspoon of this, a tablespoon of that. Child, you better listen to your ancestors to tell you when to stop. You don't need a lot. So don't be filling it a half and all of that, depending on how big your spray bottle is. Get you some dishwashing liquid. Put you some dishwashing liquid in there. The dishwashing liquid is used to make the neem oil stick to the plant. Fill that bad boy up with water. And see, I got put up on game by the copper insecticide that I done told y'all about. So I put that up in the mix. And see, I have not a big garden. Let's say my garden is medium size. So I got one of those, the sprayer things. Okay, I think my thing is 2 gallons. All right. So I fills all of that up, put that copper insecticide in there. You only spray that in early in the morning before the sun comes out or when the sun sets. Because if you spray it at the peak of sun, it will burn your plant because the neem oil will burn it. So you take all of that and you spray your stuff down. And I guarantee you, you ain't got to worry about no infestation. And you even sprayed your ground. As a matter of fact, I recommend that you always treat your ground as well. Spray your ground. And I guarantee you fence to be squat. Now, the only exception that I have found, sorry, y'all, this is a garden moment. Sorry. I apologize up in advance. But those of you that's gardening, I know y'all appreciate this information. Only exception that I have found, which I know something is going on in the environment, is this year, I can't stand them damn Japanese beetles because I had to come up with that concoction also with the neem oil for my roses because them Japanese beetles was tearing up my roses. I can't stand them efforts. So that always knocked them out. So this year, I used my same little regimen. It's been working. So I have grapes. So this is the first year of my grapes fruit. And my grape tree, and I have a plum tree in the back. It hasn't fruit yet. Them Japanese beetles were swarming my grape leaves and my plum tree. I expected it on the plum tree because I had a plum tree in Georgia. And it was doing that in Georgia. Okay? That's the first time any of us had saw them Japanese beetles. And this was about 15-something years back. And all of us in the neighborhood was scratching our heads like, what are these bugs? So anyhow, this year, the Japanese beetles was swarming on my grape leaves and on my plum tree leaves. And I was putting my solution on them. And they were not dropping. Baby, I was hot. I said, wait the F minute. Something is going on. So I had to break down, and I hate that shit. I hate it with a passion. And get that insecticide 7. You gardeners, you know what I'm talking about. To get them fuckers off of them 2 things. And that's the only 2 things they wanted. And my little concoction, a neem oil, I couldn't get them off of there. And maybe too, it was because it kept raining so much too. So maybe the solution was washing off and they was jumping back on them. But I had to break down and get that 7. And that got their ass totally off of them, out of the yard, and they were gone. Okay. So sorry for going off on this tangent. But I'm just telling you that what they're so far explaining to me with this pest and all of this and making tomatoes redder, that's no justification for gene editing. But let's continue. This intervention is already in the process of being licensed in the hope that it can soon be marketed and farmers will be able to buy the new seeds. Peep game. Y'all get that? Farmers will be able to buy the new seeds, so the genetically engineered seeds. So, the ancestors put me up on game 4-5 years ago. Start collecting seeds. Get the heirloom seeds. Get the organic seeds and store them. When you grow your stuff, store some of those seeds. Thank you, ancestors. Thank you. It's appreciated. Thank you. In another project, we actually increased the tomato's ability to bind with a positive fungus that, I'm just scratching, that protects it against disease and pest, which allows for more efficient biological pest control and reduction of chemical pest control measures. Again, I'm going to tell y'all, if you use the natural elements that nature provides, and I'm going to tell you something. Now, I'm sorry I got to go back into gardening, but they brought it up now. It's minding my business. And they had to bring it up just on something that I so happen to know about. The key also to keeping disease off of your plants and insects is the health of your soil and the fertilizer. Not that manufactured fertilizer, natural fertilizer. Natural fertilizer. Because the healthier your plants are, they naturally become, they're strong enough to develop their immunity, their immune system to fight off the bugs. Just like you, when you eat healthy, and if you take natural vitamins, it's harder for your immune system to be tampered with. Okay? So, here, I'm back to the article now, y'all. Here, we are in the process of registering a patent. Child. Gene editing is also taking place in the realm of ornamental plants. Research is underway in Israel to determine whether CRISPR technology can be used to step up the rate of growth and to enhance the pleasant scent of petunias. And I never could pronounce them right. I'm just going to say mums. Y'all that's gardeners, y'all know which mums I'm trying to say, the ones that start with the CHRY mum. I think it's chrysanthemums, something like that. In Japan, too, labs are working intensively in this area. One of them from the University of Tezuka succeeded in editing a gene in the morning glory plant so that its flowers, petals are white instead of purple. But why? The purple is so pretty. Why would you want to edit that? Work is underway at Tel Aviv University on CRISPR intervention that sounds quite dramatic to solve one of the major problems in agriculture, the unnecessary killing of farm animals of the undesirable gender. Woo, baby! Let me sip this water. Sis Tressie, I'm officially out of my water, baby. And it was full when I started this. Wait a minute, so now they say now, what now? The unnecessary killing of farm animals of the undesirable gender. The scientists involved, Professor U.D. Quimbron, I'm just going to pronounce their first names. I don't feel like all this. Ariel and Moti and Dr. Ido have used gene editing successfully on mice DNA. I already know where this is going. I already know. I already know where they fixin' to go. They use the process on the Y chromosome found in male mice so that immediately after fertilization, embryos containing it would not develop. Thus, only an encounter between two X chromosomes can produce a mouse, and it can only be female. Child, clutching my pearls. Now, baby, let me tell you something. I'm going to have to bring it back up. Yeah, I'm going to have to bring it back up. I'm fencing to have to bring this back up. Cause remember when I had put a podcast out, and I will be attaching that podcast to this podcast, about the decline in the Y gene and how they already know that the Y gene has an expiration date on it. Y'all remember that? That's okay. I'll refresh your memory. I will tag that particular podcast. Y'all remember when I went over the comparison of the XX and the XY? Y'all remember all that? Y'all remember me having discussions on how on this planet the XX is the oldest and the original, and the Y is a derivative of the X? Some say it is a mutation. Some say it's a deformity of the X. And a lot of men got in their feelings. They got hot. Of course, which I didn't care, and I still don't care. So here we go. I'm just going to read that again, because see, a lot of y'all be thinking I just be saying stuff to be saying it, or I'm saying it to male bash. No, it be the facts. It be the facts. Have used gene editing successfully on mice DNA. They used the process on the Y chromosome found in male mice so that immediately after fertilization, embryos containing it would not develop. Thus, only an encounter between two X chromosomes can produce a mouse, and it can only be female. The researchers are moving on to poultry, or chickens, y'all. Poultry, my country self. Specifically to layers of eggs and to large mammals in the agricultural industry. The egg industry relies solely on female chicks. Male chicks are typically fed into grinders upon hatching. Dang! Oh, baby! Poor male chickies. Indeed, many millions of live male chicks are disposed of around the world in this horrifying way every year. The dairy industry, for its part, also needs only female calves, so millions of males considered to have no economic value are annually slaughtered at a young age. Child, I didn't know that. Child. efforts to alter the DNA of animals have achieved their goal in many cases, but have also produced quite a few surprises and unexpected side effects. In one case, researchers in China tried to reduce fat in rabbits and along the way caused the animals' tongues to become exceptionally long. Oh, y'all can do all that. But you can't master reducing fat cells. Oh, okay then. I'm just saying. You can gene edit and slice and snuff out the Y gene. But when it comes to fat cells, you had adverse effects. You know what? Y'all ain't about nothing. When they tried the procedure on pigs, it led to the emergence of an unnecessary, oh my God, dang, doggone it. It led to an unnecessary vertebrae in their spines. Whew. In general, as Wall Street Journal survey of the subject show, the larger the animal, the more complications that ensue. Okay. When researchers in New Zealand tried to bring about a minor genetic change so as to lighten the pigment of cows' hides so they would suffer less from sun heat, the newborn calves did not survive. In another case, an American company created a herd of hornless beef cattle. The animals became celebrities and were featured on magazine covers, but then it turned out that they now carry genes that strengthen their resistance to antibiotics. Scarier beagles. These examples provide graphic illustrations, y'all sure did, of the potential threat posed by CRISPR and the deep fear that accompanies it. Okay, so I just want to remind y'all, this brings into play to me what those mythology pictures were showing you also. That was the adverse results of them doing genetic editing back then. We don't really know what the far-reaching effects could be of seemingly small genetic changes. In addition, the tool in question is so efficient that almost anything can be done with it, including rather grotesque things. At the end of 2015, for example, Chinese scientists showed that they had succeeded in altering embryos of beagles so that the dog's muscle mass would be doubled. Why? They a little bitty dog. The goal was to make them more efficient for police and army missions. Ciao. The possible dilemmas became especially acute, of course, when we come. Well, now let me back up. I don't want to go past that. So y'all have been sitting up on your behind doing it to animals already. Like we always know y'all do. Cause this is disclosure basically of that Annunaki gene editing technology. This is the disclosure. The possible dilemmas became especially acute, of course, when we come to editing human DNA. Child, let's hit it. Theoretically, CRISPR technology could be used to influence human traits caused by a particular segment of DNA. Child, you gonna, well, I already suspected that they've been doing this. Again, I go back to Inky now. All right. For example, to help develop certain psychological traits in embryos or to produce enhanced capabilities such as enhanced physical strength, improve stamina after limited hours of sleep, or heightening powers of vision. What do you mean by heightened powers of vision? Article. What do you mean by that? And when I think of the enhanced physical strength, enhanced physical strength, that once again reminds me of going back to those Sumerian texts talking about them Annunaki and them with their gene editing and how they created beings because they didn't want to work. And how they had to do different iterations because their first experiments out the gate wasn't working. It is not out of the question that in the future we will find the genes that cause attention deficit disorder. Aaron, a Nobel literature in chemistry from the Techion Israel Institute of Technology, says, would you want to edit out the genes in your next pregnancy? The technology will easily make it possible to have children according to choice. Height, talent, hair color, eyes, and so forth. Child, let me tell you. And I ain't planning to have no children. Anyway. But I sure wouldn't want to be having none now, honey. With all these shenanigans they have going on. It can be ruled out. It can't be ruled out that in the future, a country that does not adhere to the ethical disciplines of the rest of the world, North Korea, for example, will create embryos that are resistant to chemical and biological weapons and will thus forge a generation of enhanced soldiers. Child, if they don't stop with this foolishness. I mean, really. And then, family, it also goes into play once again when they were talking about in those different ancient texts about gene editing. Just goes into play how unethical it was out the gate. It's not natural. But let's continue. Scientists and other professionals across the planet are actively weighing in the moral debate over the Crispr technology. In fact, Dodna and Charpenter have established an international consortium of scientists, jurists, philosophers, and politicians that meet every few years in order to discuss where the red line should lie in gene editing, particularly in human beings. Now, I'm not trying to say that consortium of folks, of scientists, are corrupt. I'm not trying to say that. I don't want to put that on you all, because they very well may have good intentions. But we know degenerate behavior, right? We know degenerate behavior that, quite frankly, to me, they weren't natural to this realm to begin with. based on the things that they have done on this planet and continuously do on this planet. This consortium may have the best intentions, but what about the true, real degenerates? An international conference on the subject is scheduled to be held in London next month. The topic is being discussed in Israel as well. At a conference on bioethical challenges organized jointly last month by Van Leer Jerusalem Institute and Bashar Academic Community for Israel Society, one session was devoted to the topic, gene editing. Are the good and the bad separable? Child. Why don't y'all just go back to those Sumerian texts and you tell me if they are inseparable, or are they separable? The speakers in English via a video conference were Professors Doudna and Shavanover. What ethical boundaries should be set for CRISP? Shavanover asked his colleague, when CRISP is used to treat or cure a patient who is suffering from a disease like sickle cell disease, the treatment affects only that individual, Doudna noted. It's not a change to a DNA that is creating heritable alterations that can be passed to future generations. The difference is in CRISP and using CRISP in what's called the germ line. Oh, baby, this is deep. This is deep. The difference is in using CRISP in what's called the germ line in embryos, eggs, or sperm that create heritable changes to DNA, meaning that those changes are passed on to future generations. She added that this dilemma surfaced from the outset and that as early as 2015, a conference was held in California to consider possible germ life editing. Could it happen? We agreed that yes, it could. Should it happen? We agreed that probably not right now. So there you have it. I tried to give her the benefit of the doubt, but there you have it. This is disclosure, fam. Make no mistake about it. This is disclosure. Sis Hanover basically agreed with Doudna about the need to ensure responsible use of CRISP, though he also noted that putting limitations on the use of the technology might also affect the quality of research. Hence, go look at that ancient African map showing those creatures underground. I immediately thought that it was genetic manipulation, genetic experiments gone wrong. So we should be very careful about what we are doing because we might obliterate the expansion of knowledge and the acquisition of new knowledge. Now it was Doudna's turn to agree that scientific progress should be encouraged, but that it needs to be responsible progress. Child. And who gets to make the determination and the decision what is responsible, though? That's me. That's me. Who gets to make that determination? I mean, really. But I'll continue. In many countries, including Israel, the law forbids genetic intervention, human cloning, or genetic alteration of reproductive cells. With regards to experiments on embryos, the scientific community agrees that they are permitting only up to 14 days after conception, because after the embryo's nervous system starts to develop. Even so, the temptation to carry out human genome editing is great, as Dodna and Charpentier saw in November 2018 at an international conference on gene editing in Hong Kong. To the astonishment of the participants, Jiainku, a genome editing researcher at the Southern University of Science and Technology of China in Shenzhen, announced that he had succeeded with the use of CRISPR technology in editing the genome of Chinese twins Lulu and Nana. That's what wasn't her name? Nana. That's the Nana is the derivative name of Inky Nim's sister that was the geneticist on gene editing. So I caught that Chinese geneticist man. I caught that. And Lulu. I caught that too. That's straight from the Sumerian text. Straight from the Sumerian text. Lulu Nim was the second creation. They better stop playing with me. I told y'all these people are using this old technology. Lulu, according to the Sumerian text, was really the first creation and Adam Nim was the second. Now they gonna stop playing with me. You gonna stop playing with me? I know exactly where y'all got this stuff from. You just putting it forth in the public. And if you want a really good read, for those of you that don't follow us on the live, breaking all of this stuff down, it's called The Wars of the Annunaki, Nuclear Self-Destruction in Ancient Sumer by Dr. Chris H. Hardy. She gives you all of the breakdown. And she's not making it up. She's using the Sumerian text. I'm just, child. Nenma was the geneticist. She was the engineer. Child, I had to reopen the book. But yeah. Damn it. I just can't with them. Sorry, y'all. Let me just go back over that. I apologize. They think they slick. So, oh boy, a genome editing researcher at the Southern University of Science and Technology of China announced that he has succeeded with the use of CRISPR technology in editing the genome of Chinese twins Lulu and Nana, so that one of them was born immune to infection by the HIV virus. Jiainku related that he had disabled the CCR5 gene, which is responsible for producing the protein by means of which HIV penetrated the cell in fertilized eggs of 7 sets of parents who had undergone fertility treatments. Lulu and Nana, he said, were the product of the only treatment that had resulted in a successful pregnancy. So I'm going to leave it alone, but y'all need to read between the lines of what they're saying, that he had disabled the CCR5 gene, which is responsible for producing the protein by means of which HIV penetrated the cell in the fertilized egg. So y'all use deductive reasoning with that HIV stuff. Okay? It ain't something that the conspiracy theorists hadn't already done said. But I'm fencing to continue. Since then, it has been discovered that a third infant was born after such experiments, but her fate is unknown. Well, yeah, we need to know, we need to follow up. Or is that infant, did she have, or he have adverse effects, and y'all got to keep her or him in a lab somewhere? The global scientific community immediately condemned old boy, and that's me saying it because I don't feel like keep pronouncing his name. The authorities in China also grasped the enormity of the drama and placed him on trial, resulting in a 3-year prison term. Yeah. Oh, okay. That's what y'all, that's the official story y'all want to stick with. You think that he went public with that, knowing that it was against, quote, quote, supposedly and allegedly China's rules? Just for the heck of it, knowing that supposedly and allegedly he was going goes to jail? Oh, okay then. Or was his entire research project funded and approved out the gate? And don't think that it has not slipped past me all of this, quote, quote, supposedly and allegedly coming out of China. I'm going to let that sit with y'all as well. Read between the lines. Because unfortunately, I can't say what I really want to say, but y'all know what I am saying. How could gene editing affect the fate of twins in question? As Time magazine noted, Chris sometimes makes mistakes, like a text featured on a computer that creates a completely new word. In other cases, it does not edit out the repaired section methodically enough, with the results that some of the cell genes are edited while others are not. Experts who examined some of the evidence Jianku presented thought that this was exactly the case with the twins. Not all the cells had undergone editing, so the procedure did not necessarily protect them against HIV. In addition, dispersing with the specific gene could have further consequences, such as making the girls more vulnerable to other diseases, including flu. And let's say that the 2 girls grow up healthy. What will happen when they will want to have children? Exactly, article. Would they be given permission to give birth to infants who will inherit a genome that underwent editing? Yeah, that part. We know very little about the fate of those 2 girls right now, Donna said, in reply to a question from Hanover about the controversial procedure, but it's clear that the announcement sparked an international outcry in which scientists around the world said, this should not be done, this is not right, we should not be using the technology in that fashion, at least not now. Okay, there go that not now. There go that not now. Juanku is not the first or the last person to edit DNA of human embryos. But as far as is known, his altered embryos are the only ones to have been implanted into a woman's womb. They better stop playing with me now. Child, it's some X-File type stuff. Now, they saying as far as they know. Okay, article, I'm glad y'all threw that up in there because you want to say, listen now, that's as far as we know. Hint, hint, wink, wink. The other experiments done on embryos were always for research purposes only. Blink 75 times. Blink 75 times. Now, I'm just going to put this up in here. Women, this is why it was always important for you to guard your womb like it was sacred. Just what we are reading up into this article, all this slicing and dicing, creating an embryo, implanting it into the womb, this, that, and the third. This just once again proves why, number one, it proves your importance on the planet. It proves, I'm going to say that, your importance on the planet, because the planet is feminine. It also proves how you should be guarding your womb and treating your womb as sacred. So that goes to who you allow to enter into your womb. Yeah, I went there. Sure did. Who you allow to enter into your womb to place their DNA. Everyone ain't worthy. And I'm going to say most ain't worthy. You are that gatekeeper. That responsibility is on you. You make that decision. And you are to make it wisely. You have the power to breed out degeneracy. Let me roll that back. With your womb, you have the power to breed out degeneracy. So, all right, let me get that was my little moment. Let me get back to this article. In fact, the first research study that involved gene editing in embryos was conducted in China in 2015 when scientists succeeded in editing out the gene that causes thalassemia. So that was that blood clotting disease, y'all, in embryos. Already, then, the researchers noted that their results reveal serious obstacles to the use of the methods in medical applications. In 2020, an article in the journal Cell, researchers from Columbia University showed what could go wrong in embryo editing. In an experiment conducted solely for research purposes, using exactly the same technique as Jiankui, it turned out that in half the cases, the editing caused unintended changes, such as the loss of an entire chromosome. Child, they making me scratch. Doudna is well aware of these grim scenarios, as she's noted in the conference last month. There's a saying that you can't put the genie back in the bottle. You can't unlearn something once you've learned it. So I don't think it's realistic to think that we can unlearn how to do germline editing with CRISPR, for example. But we can certainly encourage responsible use by parties who have access to it around the world. Child, scratch, 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 scratch. Family, they have already, this go back to what folks are calling ancient times. This goes back to before the recorded history. This is how all of these different species got on this planet. This is exactly how all of these species got on this planet. They did various iterations of gene editing until they could get the species to look like the original people that were already on the planet. Okay. And or, which I think we already, girl in War of the Annunaki, she already kind of said what they done. They created the embryos. And then I think it was Brother Nuwa who said, well, how did they do it? Did somebody have intercourse with somebody else? I said, nope. They artificially inseminated. So, in other words, the gene editing beings were artificially inseminated into the Anunnaki women being. Now, that's coming straight from the War of the Anunnaki text. As a matter of fact, I think it was Inky's old lady who was the surrogate. Yeah, it was Inky old lady that was the surrogate. So that's why Inky and his wife are known as their parents in those Sumerian texts. And that's why Inky to this day is revered highly as the father of humanity. He saved humanity. He saved his creations. So from there, fam, because remember, there was already original indigenous people on the planet. Now, that's according to the Sumerian text. So then, of course, as things go, folks started mingling and having children together and mixing bloodlines, wooda, 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 and here we are today. And hence is why there is degeneracy in the gene pool. Yep, I sure said it. Yep, I said it. And so when I say we are all not the same, I minx what I say, and I say what I minx. because we are not all the same, and y'all need to get up off of that wanting to throw white people up under the bus. I mean what I said. You better start basing about how somebody is on their frequency and their lineage. But we have been irresponsible, and I have to put this on the women. You've been irresponsible with your womb. You know, folks that man was a degenerate. And if you didn't know, you can look at his pappy, look at his grandpappy, and know they was degenerates. But now you in love, and he ain't no degenerate. Not taking into account somebody's gene pool. I'm just saying. It is much deeper than what we think, but the responsibility is very much so heavy. So when I come to you all talking about your bloodline, sweeping around your own doorstep, cleaning up your bloodline, I've been telling you all that for years. I ain't just woke up out of the bed and said that. I mean what I say. But let's continue. The Nobel Prize awarded to Dodna and Charpentier is precedent setting in another way. It marks the first time women won the prize in a scientific category without sharing it with any male colleagues. Yeah, I know Inky's sister can relate to that, as Inky gets the credit for the quote creation when it was really his sister. But let's continue. In a short video documenting Dodna's minutes after it was announced that she was a co-winner, she is told about the precedent and finds it hard to believe. Really? Never, 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 she repeats with general amusement. Indeed, a look at the list of Nobel laureates in chemistry turns up 178 men, mainly white, and just 7 women, one of whom Israel's Professor Ada Yonath. Child, I ain't finna even comment on that because folks want to play crazy when we tell you this is a patriarch system and society, but yet the patriarch system and society sure been using all of the feminine stuff. I'm just saying. And nah, it ain't man bashing, it's facts. Dodna, who was born in Washington, D.C. and moved with her family to Hawaii at age 7, says she dreamed of becoming a biologist from a young age. In Hawaii, an exotic locale bursting with nature, she found herself a curious child asking many questions about her surroundings. Her father, an English literature teacher at the University of Hawaii, spotted his daughter's passion when she was just 12 and gave her the book, The Double Helix, written by the discoverer of the structure of the genome, the Nobel laureate James Watson. From there, she went on to study chemistry in high school, finished an undergrad degree in biochemistry, and completed her PhD at Harvard Medical School under the tutelage of yet another Nobel laureate, the geneticist Jack Szostak. When I was growing up, she tells Haaretz, it was a woman scientist researching cancer who redefined my image of scientist and inspired me to pursue my passion for chemistry, despite being discouraged from it by many others. We need to celebrate the contribution of women researchers, mathematicians, and engineers. Women, she adds, are constantly making remarkable discoveries that will impact the future of our society. Science is better because of our diversity in backgrounds and perspectives. Child, now I did not expect for this article to take that long. Yeah, honey, we can't go over nothing else. Only thing else I'm gonna give y'all, I'm gonna put at the bonus of this video when I was telling y'all about them eye drops that can improve your vision, and that's if I can find it. So the other stuff I had, y'all, that's gonna have to be a separate podcast. Sis Tressie, as usual, phenomenal, fine. You done set up here and blew my locks back. Again, this is from Heretz.com, HAARETZ.com. The article title is A Decade After CRISPR Discovery, the Unimaginable Outcome of Gene Editing Emerged. I will put the link to this particular article out there. Now, just a disclaimer, I had a problem opening it. So if you do, on my computer, so open it on your phone to get to it. Child, that's all I got to say on this. Whoo, honey, I'm tongue-tied. I'm tongue-tied, brain racing, all of this type of jazz, so forth and so on. So, family, that's going to be it for this. Thanks again, Sis Tressie, for such excellent information. Family, I'm trying to get through the information that you're sending me, which I truly appreciate it. You all be up on your stuff. You're sending great stuff. You can send it to the email, but just know, unless you reach out to me in the comment section on the YouTube videos, it may take me longer to get to that. The quickest way to send me information is to hit up the Instagram inbox, or hit up Messenger, or hit up the Facebook Messenger. Okay, but it is truly appreciated, child. Y'all really be bringing it. It's much appreciated, and I highly encourage those of you that aren't subscribed to hit the subscription button or the subscribe button, like and share. This is Rhonda with WTUZ Radio Podcast. I wish everyone well on this Wednesday. Peace and love, family. Okay, here is the bonus material that I was speaking of earlier that I promised you all if I find it. I am going to have to read it. I was hoping that I could find that segment that I saw it on for the visuals, but I can't find it, so I'm going to have to read it to you. So let's just do a little bit of technology here. All right, and let's get to this. So this is from the Indian Express. I did see just a couple other actually only one other one put this out, but I saw it as a news story. I just can't remember which news publication I saw it in. But this is new eye drops offer an alternative to reading glasses. Because the eye drops reduce pupil size, they also make it harder to see in the dark, so they are not recommended for people who drive at night or need to see well in low light for other reasons. Okay, so now that's interesting because I don't remember them seeing it up in the news story, but that's okay nonetheless. An eye drop that improves close-range vision could make misplaced reading glasses less of an inconvenience for many of the 128 million Americans who suffer from age-related deficits in near vision. Vuity, which became available by prescription, which became available by prescription this month, is a once-a-day treatment that can help users see up close without affecting their long-range vision. Okay, well, sorry, I ain't going to be using that if you're going to say I can't see up in the dark. I'm okay with that. But nonetheless, let me continue. For anybody who doesn't want to fiddle with reading glasses, this might be a really helpful alternative, said Dr. Scott McRae, And eye doctor, child, I'm not trying to pronounce that. I just did 2.5 hours of reading. Sorry, fam. At the University of Rochester Center for Visual Science. McRae was not involved in the clinical trials for the drug, which was approved by the U.S. Food and Drug Administration in late October. Nearly 90% of the U.S. adults over 45 have problems with close-range vision, a condition known as presbyopia that typically worsens over time. To focus on close objects, the eye lens must change shape, yet it becomes less flexible as people age, making this process difficult. Oh, okay, so that's interesting. I didn't know that. Your ability to zoom in decreases, McRae said. People who suffer from, I'm just going to say needing reading glasses, often find that they need to hold a book at arm's length or turn on a bright light to read it, says Dr. George Waring, an eye doctor and medical director of the Waring Vision Institute in Mount Pleasant, South Carolina, who led Vuitti's clinical trials for the pharmaceutical company Allergan. Typically, eye doctors recommend that people with reading glasses wear over-the-counter or prescription reading glasses when they need to see up close, but Vuitti may also be an option for them. Vuitti improves near vision by constricting the size of the pupil. It makes the pupil small, creating what we call a pinhole effect, which reduces the amount of peripheral light that passes through the eye that can make it hard to focus, said Dr. Stephen Orland, an eye doctor at the University of Pennsylvania School of Medicine, or Pearland School of Medicine. Vuitti's active ingredient is a drug called pilocarpine, and it is not a new medication. Oh boy, let's see where they done got this from. It's actually one of the oldest drops we have in the eye doctor industry, Orland said. It has been used for decades to treat, glaucoma, a condition characterized by the damage to the optic nerve. Although Vuitti is the first product of its kind to treat needing reading glasses or near vision, at least 9 similar eye drop products are in clinical development to treat it and may be available in the future. Warren and his colleagues presented the results of their phase 3 clinical trials, which has not yet been published in a peer-reviewed journal, at the 2021 annual meeting of the American Society of Cataract and Refractive Surgery in July. A single Vuitti drop in each eye improved trial subjects' close-range vision for 6 hours and improved their intermediate vision, important for computer work, for 10 hours. Vuitti's benefit over reading glasses is that it does not impair distant vision as reading glasses do. Usually, when a person stops reading to do something else, they need to remove their reading glasses to see around them properly. That's the good part about this. The drops don't really affect distant vision under normal daylight conditions, McRae said. But yeah, the fact that you can't see in the dark, though. But anyhow, McRae also noted that Vuitti will work best for people who only have mild to moderate, farsighted or needing reading glasses, which probably means people between the ages of 45 and 55. Older individuals with more serious problems may find that the eye drops do not improve their near vision enough to make a difference. Oh, okay, that's interesting. VUITY does not correct regular nearsightedness, farsightedness, or astigmatism. It improves only the age-related deficits in close-range vision. Okay, so in other words, if you got, if you can't see without your glasses properly and all of that, or if you ain't an old head, let's make this stuff simple. If you ain't an old head, that every time you got to read something in small print, you moving it all the way back, and that ain't working, so you got to put on your reading glasses, then this ain't for you. It's basically what they trying to say. So people with other eye errors will want to continue wearing glasses or contact lenses, even if they use VUITY. Okay, so that makes sense, McRae noted. And the drops are not meant to replace reading glasses entirely. Warren said people with nearsightedness will probably want to own reading glasses too, but VUITY may reduce the amount of time they need to wear them. For some people, it's going to work great. Okay. VUITY is not typically covered by health or vision insurance, and Warren said it might cost around $80 per 30-day supply. Although the clinical trials did not report any side effects, 14.9% of the subjects who took VUITY reported mild headaches. I can see that, compared with 7% of subjects who took placebo drops. Up to 5% of subjects taking VUITY reported other side effects such as eye redness, blurred vision, eye pain, visual impairment, eye irritation, and an increased production of tears. Because the eye drops reduce pupil size, they also make it harder to see in the dark. So they are not recommended for people who drive at night or need to see well in low light for other reasons. Okay, so this article appeared in the New York Times, although it didn't come up in the search on New York Times search didn't come up. So anyhow, family, this came, maybe that's why this came up first, because it came out today. The Indian Express, and this is new eye drops, offer an alternative to reading glasses. So I just wanted to include this in the bonus material since I talked about it, and I knew this would be relatively quick. So this is yet another example of how technology is moving pretty fast. And this is just a small one. I'm assuming, although you can get LASIK surgery already to help with your vision problems, and for cataracts, same thing. I think they're using LASIK now. Don't quote me on that. Or they will, think the old surgery, they were cutting the cataract, but I think now even for cataract, they use lasers. So even with that, technology has advanced, and now they're talking about drops. So don't be surprised if the next step to this, they're going to release that they can now make blind people see. All right. So I just wanted to give you all this quick bonus. Thank you all so much, family. Peace and love.